Now in this video we will recap time and space complexity of all operations that we have learned till now on a single linked list. The first operation is creation of single linked list. Here the time and space complexity is constant time operation because we have to create head and tail and first node which takes constant time, and similarly for space complexity we have to create only one node and two reference variables. So this is also a constant space complexity operation. So the next operation is insertion. Now in case of single linked list we have three cases in insertion. So we can insert an element at the end of single linked list, we can insert an element at the beginning of single linked list, and we can insert an element at any given location. So if you are inserting an element at the beginning of single linked list, in this case the time complexity is O1, but if you are inserting the element at the end of single linked list and at any given location, then in this case time complexity is On, because in this case we have to traverse through the all nodes until we find the location that we want to insert node. So that's why traversing will take On time complexity. Now the space complexity is O1 because in each insertion we are inserting only one element to the single linked list. That's why the space complexity is O1. Now the next operation is searching operation. Now in case of single linked list, when we are searching an element, we are searching linear search. So this means that we are traversing through all elements of single linked list and checking that if this is the element that we are looking for or not. So if the value of node is equal to the value that we are looking for, in this case we are returning saying that the node is found at the current location. So this means that in the worst case, if the element that we are looking for is located at the end of single linked list, in this case we have to traverse through the all nodes and checking that if this is the node that we are looking for. So when we reach the last node we will say that this is the node. So this means that if the number of elements in single linked list is n, so the time complexity will be On. Now space complexity is O1 because in this case one more time an additional memory is not required. We are just traversing through the all elements of the single linked list. Now the next operation is traversing. Now it's obvious that when we are traversing through a single linked list, we have to visit all nodes of single linked list and printing out their values to the console. So this means that if the number of elements in single linked list is n, so we have to traverse all elements of the single linked list, so the time complexity will be On. Now the space complexity in this case also O1 because here also an additional memory is not required to perform this operation because we are just visiting the nodes and printing out their values to the console. Now the next operation is deletion of a node from a single linked list. Now here also we have three cases. We can delete a node from beginning of single linked list, we can delete a node from the end of linked list, and we can delete a node from any given location. Now in case if we are deleting an element from beginning of single linked list, in this case time complexity is O1, but if we are deleting an element from any given location or from the end of single linked list, in this case time complexity is On because we have to traverse through all elements until we find the node that we are looking for to be deleted. So after finding it we are going to delete it. So this means that for finding this node it will take On time complexity, then we are going to delete it. And the space complexity is obviously that it's O1 because in this case we are just deleting a node from single linked list. Now the last operation is deletion of single linked list. So in this case the time and space complexity is O1 because when we are deleting an entire single linked list, we are just setting head and tail references to null. So this operation is not time consuming, that's why it takes O1 time complexity, and the space complexity is O1 because all elements will be deleted from the space. So with this lecture we have completed section of single linked list. So here we have explained all operations that we can perform on single linked list, and we have explained time and space complexities of single linked list. Now hopefully everything is clear about single linked list. So see you in the next section.